Good morning, dear students. On the last turn, we have discussed the general properties of the lipid. Today, we will discuss the chemical properties of the lipid. Regarding the chemical properties of the lipids, first property we could consider is our hydrolysis. Hydrolysis, I think you have studied the notes provided on the WhatsApp site. So, first property is hydrolysis. In hydrolysis, fat with alkali or enzyme lipase gives fatty acids plus glycerol. Lipase breaks fat in steps as from triglycerides to diglyceride to monoglyceride and finally glycerol and also one fatty acid at each step. You could see here, this is the triglyceride. Lipase gives first fatty acid, then diglyceride, then second fatty acid, and ultimately monoglyceride, then finally gives glycerol plus the last fatty acid. So when we talk about the hydrolysis, in hydrolysis in three ester linkages are broken to give fatty acids. Thus, fat or oil plus water in presence of lipase gives glycerol plus 3 fatty acids in 3 different steps. This hydrolysis or lipolysis actually is a energy yielding process where during hydrolysis heating during frying produces free fatty acid and it increases due to high H2O or frying of food where the food is moist materials. In case of hydrolysis or lipolysis, moderate lipolysis is used for cheese production and complete hydrolysis or lipolysis is used for free fatty acid for soap formation. When this hydrolysis is proceeded with alkali, this forms, in this case, fatty acid react with alkali to form salts, and these salts are nothing but soaps, and this process is called saponification. You could see here the triglyceride plus 3 NaOH at 40 to 120 degrees centigrade gives sodium salt of the fatty acid plus glycerol. These soaps of sodium and potassium are water soluble and are used for cleansing purposes. So when hydrolysis is done or proceeded with the sodium hydroxide at this particular temperature, this reaction is known as saponification, and in this saponification fat or oil plus 3 NaOH gives glycerol plus 3 salts of fatty acids, and these are actually nothing but these are soaps. In case of hydrogenation, the unsaturated plant fat, which is actually oil, by catalytic hydrogenation is converted into more saturated or solid fat. So in this case, oil plus hydrogen in presence of nickel catalyst is converted into more saturated product, and this results into less M saturation. So generally this is over finely divided nickel, and in this case vegetable oil plus hydrogen gas in presence of nickel powder under pressure produces solid fat. The next property we could discuss regarding the um, lipid is our oxidation. Oxidation of fats in air is associated with the hydrolysis. Oxidation of double bond along with the oxidation at double bonds results short chain acids, aldehydes, etc. This along with fatty acids produced during hydrolysis gives a less palatable taste and odor to the fat, and this is the rancidity process. Antioxidants like organic compound prevents oxidation. Example tocopherol, natural vegetable oil, and tertiary butyl paracrysol. So when we talk about the oxidation, in this case oil or fat with free oxygen in air in presence of heat or metal adversely affect flavor and causes oxidative rancidity. There may be auto oxidation as well in air at room temperature, and this produces radical chain process, and this may be during frying of foodstuffs where oxidation increases the free radicals, so adds add antioxidant in order to minimize this oxidation. So these are certain chemical reactions. The last chemical reaction regarding the lipid we could discuss in the form of polymerization. Polymerization, where small molecules of oil or fat combine to form much larger molecules, as in deep frying where temperature should be more than 177 degrees centigrade in presence of oxygen. It results in forming of oil. So these are the certain chemical properties of lipid or fat that we should always keep in mind during the discussion of the lipid. Now we are having certain rules of fats. There is a question in your you could have this question in your question paper that discuss the biological roles or different roles of lipid. So in order to discuss the roles of lipid, we should know the different aspects, the different sites where we could see the lipid. The first role in for the lipid we could have is this the energy source in animals and fat rich seeds. Have you ever seen groundnut seed? You eat it, and that gives you a thickened layer over the tongue. This is nothing but this is the rich lipid that is present inside the seed. Second role we could discuss as storage of fat soluble vitamins. If we talk about the vitamins, we are having certain vitamins which are actually fat soluble in nature. So that is also, in that case also, lipid acts as a storage of fat soluble vitamins. The third role we could discuss as constituent of hormones and fats. Lipid is present as one of the part of the hormones and fats. The next role we could have as a part of cell membrane plus inner membrane system. As you all are knowing that the cell membrane is basically made up of lipid and protein. Lipid bilayer plus proteinaceous entity. The fluid mosaic model describes very well the organization, 3D organization of the lipid and protein, where we are having a layer of lipid along with the extrinsic and intrinsic proteins, and this ultimate structure is responsible for the various functions of the plasma membrane or cell membrane. Besides this cell membrane, the membrane biochemically consists of lipid and protein, and certain oligosaccharides is also present in the inner cellular membrane organelles membranes. Then the next role we could have as a transmitter, and then the next role buoyancy, and the next role we could have insulation, and then the last role we could have as protection. Example, protecting plant leaves from drying up. Have you seen ever the thickened plant leaves which are having a thickened coating, and this is due to the presence of leaves, and that leaves are being preserved due to the presence of lipid layer. So these are the certain aspects that you could discuss during the roles or functions or the sites where you could see the lipid to perform a particular function as an energy source, as a storage of fat soluble vitamins, as a part of hormone and fats, as a part of cellular membrane, as a transmitter for the buoyancy, as the insulation, as the insulator, or for the protection of the plant leaves. So today we have discussed the different chemical properties and biological role of the lipids. You might have prepared a question that what are the fatty acids, type of fatty acids, and their nature. Nature in the sense, we all are knowing that the lipid is basically made up of glycerol and fatty acids, and we are knowing that if glycerol is common, then the different fatty acid could be responsible for the different type of lipids and their structure and their function in turn. So prepare a question which should have the description of fatty acids, of oils and fats and their classification, where we could categorize the fatty acid into saturated. You might have studied the notes. The saturated fatty acid where no double bonds, and unsaturated fatty acids where we are having the double bonds. So categorize your fatty acids in the form of a table where we are having the name, systematic name, number of carbon atoms, and common sources, because in a question paper you could have the objective questions where there may be a question that butyric acid is having 4, 6, 12, 20 carbons as one of the question, or butyric acid is present in vinegar, butter, animal and plant fats. So these are the certain questions that you could have from your the section that is fatty acids. So please go through it and prepare a description of the fatty acids where you could classify it in the form of saturated and unsaturated fatty acids. I have provided you the notes regarding the different type of saturated and unsaturated fatty acids. Then for the unsaturated fatty acids, how they are named. So we are having a formula. You might have seen this formula where the fatty acid can be represented by the formula, this formula, where X represents the total number of carbon atoms, Y shows the total number of double bonds, and this Z1, Z2, Z3 are the sign to show the position of double bonds. So please go through it. You may also have a question where you could have the formula like this, and on the basis of this formula, example, linoleic acid is having this structure could be represented as like this, 18 is to 2, like this. You could have a question that this formula represents a particular fatty acid, and that may be linoleic acid or some other acids. So as the multiple choice question, you could have this, and then you could have a one more question from the section of fatty acids, where the sandalic acid, nimotinic acid, and some other very important fatty acids are there, where that could be assessed their source and their role. Then the next and last section you could have in your question paper, essential and non-essential fatty acids. So what are the essential and what are the non-essential fatty acids could be asked there. You could have a question that human body cannot synthesize a very important fatty acid named as linoleic, arachidonic acid. From any fatty acids, you could have a question. What are the fatty acids that the human body cannot synthesize? So these are the certain aspects that you should know before solving your question paper. Then nimotinic acid is extracted from this mold, cytrovorium mold, and some other mold. So if you are knowing that nimotinic acid is excreted by the cytrovorium mold, then you could easily select that this is the cytrovorium mold that secretes the nimotinic acid, one of the very important fatty acid. Then santalic acid is present in the seed oil of sandalwood. So these are the certain things that you have to keep in mind, and for that you could discuss in your book before going to solve the question paper. Thanks a lot. In the next session, we will discuss the different type of oxidation, that is beta oxidation, alpha oxidation, and omega oxidation. So we all are knowing that during hydrolysis there is a production of free fatty acids. Why this free fatty acid is produced? We all say that lipid or fat and or oil are the richest source of energy. So that lipid or fat or oil could directly be responsible for the generation of energy, or it has to be converted into certain forms that are useful in order to generate the energy. So for that we are having the aspect of metabolism of lipid. In metabolism of lipid, we are having two different aspects, catabolic and anabolic reactions. So what is a reaction that could be responsible for the generation of energy? In the next session we will discuss the different type of oxidation reactions for different fatty acids like beta, alpha, and omega. Thank you.